Hello, everyone. This is Seth with the World of Paleoanthropology, and I'm so excited to be here once again with the show, The Story of Us, bringing experts from the field right to you, the enthusiast, the student, the fellow researcher at home. Today, I'm joined by our special guest, Professor Dr. Kevin Hatala. How are you today?
Great. How are you doing?
I am doing wonderful. I'm so excited that we are having this chat. I know that we are going to talk about some very exciting topics that people have been really dying to hear about. So, why don't we just start off with you telling us just a little bit about yourself, who you are, where you teach, etc.
Sure. Yeah. So I am a paleoanthropologist, and I am an associate professor of biology at Chatham University, which is a small liberal arts college, in Pittsburgh, Pennsylvania.
Wonderful, wonderful. And you recently, in the last few months, I believe it was in November, you and your team published findings of very exciting new trace fossils that were discovered, and they're in Kubiora, which should sound familiar to anyone who is familiar with trace fossils and footprints. And if you could, for those who might not be, could you give us a little bit of a background on trace fossils and footprints in Kubiora and kind of why you were there in the first place?
Yeah, sure. So, trace fossils or footprints in particular, I guess they've historically been thought of as relatively rare components of the human fossil record. They tend to get less focus and attention than things like skeletal fossils and stone tools and all of these other things that we see more frequently at sites all around the world. Um, but footprints are becoming much more common, I think, now that people sort of have started looking for them and kind of have a clue of what to look for when they're searching for this kind of evidence. And so we've seen this surge in discoveries of fossil footprint sites from around the world, really, within the past like 15 or so years. So these are becoming an increasingly common thing in the human fossil record and a type of data that we're starting to incorporate into more and more of our analyses. Um, and so, with this particular paper that we published in the fall, we published a newly discovered fossil footprint site from Kubiora, as you mentioned, that's dated to a little bit more than 1.5 million years ago. Now, that time window is really interesting, or that time window in this particular area is particularly interesting because, well, we know a lot about human evolution, or relatively a lot about human evolution in that sort of time and place. This is an area that was made famous by the discoveries of Richard and Meave Leakey and their family and their research team who worked there for decades. There are lots of really well-known hominin fossils that have come from this area. And we've found relatively recently that this is also kind of a hotbed for these fossil footprints as well. Those deposits are really great for preserving this kind of evidence. And so we're discovering more and more of these sites from the areas around both Ileret and Kubiora. Um, and so I had been involved in research on some of those other projects in this area of East Turkana. And then sort of for that reason, that's what led me to then ultimately be involved with this particular project as well.
Fantastic. And I have a lot of 3D prints. I have one footprint, and it is honestly my favorite 3D print because it is just so it's so different. It's a creature made that. Like it's I don't know, it's just different. And so back to, Kubifora and Turkana, tell us about this latest discovery and why it was making headlines. And also, well, we'll get to that in a moment. Why don't you tell us about the announcement?
Yeah, well, I mean, one of the things just about that source of data that people find really exciting and intriguing is, like you mentioned, the sort of relatability of this form of fossil
Hmm.
evidence. It's like something where we've all probably seen one of our own footprints before. We've seen footprints on a beach or in the mud. Like this is something that we come across in our daily lives, and something that we sort of intuitively understand at some basic level. So there's immediately that sort of excitement and interest when we get these snapshots of behavior in the fossil record. And so these footprints are capturing like distinct locomotor events. These are points in time when hominins were walking around their landscapes doing, who knows what. We have some different ideas for what they might have been doing, but it's a rare chance to actually see, like you said, living organisms sort of going about their daily
Hmm.
lives,
Hmm.
as opposed to just seeing what remains of them after they've died.
Right.
Now, at this particular site, what's really interesting about it is we think that the footprints of two different species are preserved on the very same footprint surface. And so it looks like two different hominin species that were around East Turkana at this time, Homo erectus and Paranthropus boisei, actually crossed paths on this lake, in this lake margin environment somewhere around 1.5 million years ago. Now, when I say cross paths, like that doesn't literally mean that they had to have sort of walked and passed each other at exactly the same time. But we know that they must have been living on that same landscape, that same immediate landscape simultaneously. And so they would have, encountered one another, they would have known about one another's existence. And that raises all sorts of really interesting questions then about like how exactly were these species interacting? We've known from their skeletal fossils that they were probably around at the same time. But when you find skeletal fossils, they're typically preserved in sediments that accumulate over thousands, tens of thousands, hundreds of thousands of years. And so you don't really know for sure whether those two species like actually existed in immediate proximity to one another. And so that's what's really special about this site is that it preserves evidence on such a small window of both space and time, where we can say with a lot more confidence, yes, these species were there in the same place at the same time. They were sympatric. They were both using this environment in some kind of way.
And that is just absolutely, it changes the paradigm of what we used to think, say 20 years ago, where it used to be there was one hominin at a time on the landscape per whatever ecological niche, and that was that. Now we know we have other evidence, but this is a very good piece that shows hominins lived on the same landscape. They did exist and coexist, and we don't know how they would have interacted, but that brings up so many questions and further research on trying to figure out those questions. So, what can we learn from these footprint trace fossils that we can't learn from, say, a skeleton? And obviously, there's drastically different types of fossils. Like you said, one's a snapshot of a living event, and one is
Mhm.
after something has decomposed or fossilized. But in terms of paleoanthropology and data, what
Mhm.
can you gain from footprints that you don't get from finding a skull in the ground?
Right. So this is a case where there are several examples like this in paleoanthropology, but it's sort of the scale of the data can speak to a very different scale of question. When you think
Hmm.
about like the particular like interval of space and time that needs to be captured for you to address a particular research question. Um, these data are really unique in the sense that they capture such a narrow window compared with anything else that exists in the fossil record. And so I became interested in these sources of data originally because I was interested in studying anatomy and locomotion in the fossil record. And you can learn some things about anatomy and locomotion for sure from skeletal fossils. We know that they reflect in a variety of ways, the ways in which those bones were used during those animals'
Hmm. Hmm.
lives. But they also record sort of a lifetime of information from that organism, and they're influenced by um, evolutionary patterns and other things as well, influencing what exactly a bone looks like. Whereas with these trace fossils, with these footprints, you get an actual like recording of motion. And so you can see exactly how one of these hominins 1.5 million years ago was walking across their landscape at one particular moment in time. It's almost like you get a, you know, quick little video recording almost of a hominin 1.5 million years ago. It's sort of an equivalent form of information. Now, of course, like they don't contain everything we would possibly want to know. You get only this little window of what their foot looked like and how it interacted with the ground at that moment in time. So we don't know about what these hominins looked like from the ankle up, basically. So you get an isolated picture, but at the same time, that's really, really valuable um, to use in conjunction with what we can learn from skeletal fossils to then understand what our fossil relatives looked like and how they moved. Now I'm focusing very much on the sort of anatomy and locomotion side of it because that's where my own like primary interests lie. But again, because they're recording such a narrow interval of time, you can also ask these really interesting questions about behavior and about paleoecology as well, because you can see how hominins were interacting with one another. You can get a sense of sometimes how they were interacting with other animals. And you can get this sort of snapshot of all of the other animals that were around those hominins on this shared landscape. And so there are lots of really interesting pieces that we can gain from sites like pieces of information that we can gain from sites like these that are really difficult to piece together from other kinds of fossils.
Right, right. So speaking of these two species, and I always like to say, unless we have a time machine, we can never be sure about anything. So what do we who do we think they were? Who do these footprints represent?
Yeah, so it looks like our best guess, based on the evidence that's available right now, is that these footprints represent Homo erectus and Paranthropus boisei. Now, those two species, both of their fossils are known from these same deposits in this same area during the same time period. They're present in the skeletal fossil record in roughly like 50-50 proportions.
Mm,
Um, and there aren't currently any other species that are definitively known from this particular time period. Now, there are some other species like Homo habilis and Homo rudolfensis that we know are around just before this time period. And so, there's a chance that they could still be around on this landscape at this time, and we just haven't found their fossils yet. That's always a possibility. But again, like based on the evidence that's currently available, it seems most likely the case that these are Homo erectus and Paranthropus boisei. Also, based on what the footprints look like, there are some that look very human-like. And based on what we know about Homo erectus, they seem to look much more human-like in many ways than any other hominin species that's around at this particular time. And another set looks different in some interesting ways. The other set of footprints looks more similar to the 3.66 million year old footprints from Laetoli in some
mm.
ways, actually, which is really interesting. And so we think that those more Australopithecus seeming footprints are more likely to be associated with Paranthropus boisei. Um, like you said, you can never know for sure. We don't have complete foot skeletons from either of those species, and so you can't like line up the foot skeleton with the footprint and say this is a perfect fit. Um,
Right.
but yeah, that seems mo the most parsimonious explanation at this point in time.
So was there anything that surprised you about the differences between the two prints? Like the two sets of prints?
Yeah, I mean, honestly, I was probably most surprised about how similar they look in the grand scheme of
Mm,
things. Like to I don't probably to someone who hasn't looked at hundreds of these footprints from this time period, like you look at the two side by side and they're not wildly different. It's not like one looks like a chimpanzee foot and the other one looks like a modern human foot or something like that. They both are generally human-like in their overall shape and size. But then it's like as you start to look more closely, and as we started to run these footprints through a variety of 3D analyses, then we started to pick up on some of these morphological differences between them. One of the first things that we noticed just in the field when we were excavating these is that some of the footprints have a hallux, a big toe that kind of veers off to the side a little bit more than what you would expect to see in your own footprints. Um, and those footprints also turn out to have less of an arched shape to them, which doesn't necessarily tell us about the arch of the foot, but it does tell us about how the foot was moving and interacting with the ground while those hominins were walking. And so they seem to have been moving their feet in a different way than what modern humans do today. Meanwhile, there are other footprints on that same surface that kind of look indistinguishable from those of modern people. And so the ones where we see that little bit of hallux abduction and the flatter morphology, those are the ones that we think were made by Paranthropus boisei.
And how would that affect locomotion? Like when you imagine a modern human walking, just think of, police officer giving a drunk whatever test. They're walking in a straight line. How would Boise do? Like, how would it look compared to a chimp walking straight up, I guess?
Yeah, that's a great question. Like, again, we're somewhat limited because we get the records of what's happening at the sort of intersection between or
Mhm.
interface between the foot and the ground. And it's hard to reconstruct all of what's going on from the sort of ankle upwards, what's happening at the hip, what's happening at the knee, and so on.
Right, right.
Um, but with those Paranthropus boisei footprints, like the really cool thing about those is that they actually form this very long trackway across the site. And so we can get a sense of like the pace at which they were walking and how they were
Mhm.
spacing their sequential steps. And from that, it looks like, the width of their steps was very similar to what modern humans do. They were walking at a fairly fast pace, especially considering that they were walking through mud. Um, and so it's like, in a lot of ways, it looks like what they were doing is not super different from what other hominins are doing. Um, at the same time, there is this little bit of like mobility with the big toe where I mentioned it being more abducted, but it's also more variable from step to step. Like
Mhm.
there seems to be some sign that the hallux was just sort of more mobile and they were moving it back and forth while they were walking. So it's unclear to me like exactly what impact that might have, but it might have something to do with more of like the intrinsic muscles and ligaments within the foot that just, had different anatomies and functioned
Right,
in different
right.
ways. I would guess, just based on what we know about modern human biomechanics, that if you had more mobility in your big toe, like you would probably have like greater energetic costs. It wouldn't be like as efficient a manner of bipedalism necessarily. Um, but at the same time, it's still like based on the spacing of their steps, it still looks like they were very capable bipeds. It's not like they were bad at this behavior. It's still what we think was their habitual manner of locomotion. So like if they were really bad at it, they would have been doing something else probably.
Right,
Uh,
right.
so yeah, it's probably again like more similar than what I would have expected to see, I guess.
Mhm.
But maybe in the end, maybe that's not all that surprising that they would
Right,
be,
right.
very capable of performing this behavior too.
Absolutely. And I think that brings up a lot of points of maybe we need to revisit again, as we always need to do, what is a human, what makes us human, and such and so forth. So, talking about yourself now a little bit, you said where you're a professor at. I would love to hear what got you invested in anthropology and paleoanthropology and what sparked your interest and what got you where you are.
Yeah, so I didn't have like a super early interest in paleoanthropology, or at least like I didn't probably really know what it was when I started college even. Um, and I had some sense from going to science museums as a kid and things of that nature, but didn't really know much about it as a sort of field of study and potential career. I started out in college as a biomedical engineering major. I was really interested in how the body worked, basically. And so had a lot of the same interests that I still have today, but was just approaching it from a very different angle. I was a pre-med student and thought that that was going to be my sort of career trajectory. Um, I realized pretty quickly, maybe a year into my undergraduate studies, that I didn't love that side of things or that approach
Hmm.
to this area of study. I switched and became actually first a biology major for about a semester or a year, and then only after taking a couple of biological anthropology courses, then ultimately switched over and was like, okay, this is where I think most of my interests lie. So it took some time to sort of develop that interest, and it still wasn't really until I think going into my senior year as an undergraduate where I had my first sort of like real research experience. And then after going through that, that's when I sort of recognized like, okay, this is what I really like to do. I really like this fields and the questions that are involved, and I like the sort of freedom to pursue these questions that I was seeing in my professors and mentors at the time. And that ultimately led me to pursue graduate school in this area. um, from there forward, the path was a little bit more linear. Once I landed in a graduate program and had a sense of that I really wanted to do this sort of thing. Then I went through more of the traditional trajectory of going through a PhD and then going on to a postdoc, and then after my postdoc, going into an academic position. Um, so yeah, from that point forward, it was
It
fairly
was decided.
straightforward as, I don't know, academic careers can be, I guess, which is they're never
Right,
fully straightforward, but
right. And yeah, that's the thing that I absolutely adore about anthropology is that it combines so many different aspects and ways of looking at what it means to be human. You can be a med student, you can be a poet, you can be a sociologist, and you can all come together. You should come together. I think the best work on studying the deep past is done by interdisciplinary teams. And that's how we find out where we come from. And the better idea we have of where we came from, the better planning we can do going forward. And speaking of going forward, where do you see, what are your next steps? Are you going back to Turkana soon? Do you have some things that, and if you can't talk about them, that's okay. But are there some things in the works? What's going on?
yeah, no, it's there are ongoing field projects there, which we're continuing in the years to come. Like I said, we've been finding that that is basically this like hotbed for finding these fossil footprint sites, and so there is plenty more to work on in that in that area there. Um, I mentioned a little. I went in this direction a little bit earlier, but like some of the questions that we're now pursuing, like go beyond just anatomy and locomotion, especially after
Hmm.
this most recent paper. There are some interesting questions that we're now able to ask related to like hominin behaviors and environments that maybe we weren't able to ask before. And so there are some really exciting new directions there. And we're trying to also come up with ways in which we can synthesize not only like the fossil hominin footprints, but also look at the footprints of other animals, look at those in concert with other paleoenvironmental proxies. So, what are those fossils telling us versus what are the skeletal fossils telling us? What are the plant fossils telling us? What are the stable isotopes telling us? And trying to develop new ways to piece together all of these lines of complementary data that each sample different windows of space and time, but we should be able to use those in a more sort of comprehensive, or use those in a way where we can build a
Hmm.
more comprehensive picture of what these ancient environments really looked like. And I think that's really interesting then for asking questions about what the environments were in which human-like locomotion actually emerged. Um, I was saying earlier that I was really struck by the similarities in the apparent styles of locomotion of Homo erectus and Paranthropus boisei, but at the same time they're different. And we
Hmm.
still think there are some important differences that are there that distinguished Homo erectus from the other species that were around at the same time and that came before them. It does seem like they have, some very human-like traits in that respect. And so there were certainly, or almost certainly, some important things going on still with their locomotion that distinguished them from other hominins. And understanding the sort of context in which that style of locomotion emerged is still really interesting. And I think there are lots of unanswered questions in that area. So that's what we're doing on the field side. And then also still doing a lot of work in the lab to really understand how we can interpret these forms of data. I've done a lot of experimental research as well, looking at how exactly or what exactly can we learn and what can we infer from these fossils when we find them. And so trying to understand more about the details of like how of what you can infer about foot anatomy and foot motion and things of that nature from just footprint morphology, while also trying to piece that together with what we can learn from the skeletal fossil record to really build a more complete understanding of how these hominins were moving.
Okay. That is a So that brings up my next question of, I guess, and I think it kind of answers itself. But what is the main research goal overall? Is it to discover what the original or where our locomotion originated? Is it to discover the environment that it originated in? A combination of the two? Is it bipedalism in general? What are we talking?
Yeah, basically all of the above. And so it's, something that doesn't get answered overnight or answered in a field
Right.
season. But that's, yeah, when I think about like the big picture of like what I do in my research and what I work on with my colleagues, we are ultimately like trying to ask these big picture questions about like when, how, and why did the human body come to look and function in the way it does today?
Mhm.
And so, you can answer pieces of like the when just by finding these different fossil sites and understanding like what kinds of anatomy and locomotion are present at various times and places in the fossil record. But then like the how and why are the much trickier parts to answer. That's where we need to understand more about the environmental context in which these hominins existed. We need to know more about the sort of evolutionary patterns that characterized our lineage. Um, and so that really requires like some big picture thinking and also more complicated analytical work to get at those sorts of questions. And they're the types of questions where like, yeah, you're probably not going to land on a single definitive answer to one of those anytime soon, but you can sort of chip away at them and make progress and come up with, some hypotheses for what may have happened.
Do you think, based off of the current evidence, that Paranthropus boisei could have ran?
Yeah, I mean, I would guess that they could have run.
Like, not
Yeah,
obviously, like more like a modern human, I guess I'm saying. Like,
yeah,
because
yeah.
there's something I'm about to get at that I'm thinking of, but could they have kept up a you said the track went for a while and they seem to be going pretty fast through mud.
Mhm.
Do you think, and this might not be, I know this isn't your area, but it's a behavioral question. Do you think we are maybe putting Homo erectus in too tight of a niche that they were the first hunters versus scavengers and whatnot? Do you think potentially earlier hominins could have been hunting now that we found stone tools with Paranthropus and whatnot?
Yeah, well, I guess, I mean, from a locomotion perspective, I think there is still like so many adaptations that we see in Homo
Hmm.
erectus that distinguish them from so many
Right.
other hominin species, um, where it does seem like they're really doing something different and more human-like with respect to their locomotion.
Okay.
Um, Now, that said, like I'm sure, they probably had a diverse behavioral repertoire, and I'm sure the same was probably true for contemporaneous and earlier hominins as well. I think, yeah, based on evidence, like you said, for stone tool use, for potential consumption of animal resources by earlier species as well. I think it's possible that there were other hominins that were, I don't I don't know that I would say there's like firm evidence for hunting necessarily, but
Hmm.
definitely, expanding their niche and consuming a broader array of resources than some of the hominins that came before them. And so definitely like we see just after 2 million years ago, there's evidence from East Turkana that hominins that potentially predate Homo erectus were accessing like aquatic resources, for example. Um,
Mm.
and consuming those as a part of their diet. And so that's maybe Homo habilis, maybe other species. There some hominin that was around there at that time appears to have done that. Appears to have expanded their niche in that particular way. So I think it's very possible, yeah, that there were other species doing that, but there's still something about Homo erectus locomotion that makes it stand apart, and that it probably would have had some different abilities in that realm than the other hominins that were around at the same time and before.
Okay, I think that's a good explanation, and that makes perfect sense. Now, you've mentioned a few times that Kubiora is turning into kind of a hotbed for these footprints that you're seeing. Would you say Kubiora is special, or that we just haven't looked enough, and there's probably many more sites like Kubiora that we just need to go find?
Yeah, I mean, I think that's potentially true. The way in which, I mean, when you think about like traditional paleoanthropological field methods,
Hmm.
a lot of what's done is sort of surveying a landscape and looking for bones that have eroded out of sediments. Um, Finding fossil footprints requires a different approach that isn't used all that often. It requires much more like detailed knowledge and investigation of the sediments that exist in particular areas.
Mm.
So, it involves a lot of geological studies, digging geological trenches to understand the depositional environments that exist in various places. And in many areas, like that kind of work is not done extensively. Like you'll dig a geological trench in a place where you found a hominin fossil and opened up an excavation. But it's not necessarily the sort of thing that you're doing like all around a landscape.
Mm. Hmm.
Um, and so I think there are probably some opportunities to implement similar approaches as what we've done in East Turkana in other areas, in other time periods where maybe those times and places could be sort of similarly productive in this respect. I mean, the area is a little bit special because footprints take a particular set of events to make their way into the fossil record to actually be preserved. And it seems like that series of events happened over and over and over during this particular time interval at Kubiora and at Ileret. Um, I don't know that it's entirely unique, though. Like that very well could
Right,
have
right,
happened
right.
somewhere else 4 million years ago, and there could be this other amazing assemblage of fossil footprint sites that's yet to be found. Um, but again, it requires a sort of different approach than what has typically been used in our field in most places.
And I think, what you mentioned about, finding more is that that's one of the greatest gifts anthropology gives us. Is it's the gift that keeps on giving. There always seems to be more on the horizon. And I know a couple decades ago, there were a few individuals saying that the field was kind of done. And, we've entered a whole new age of discovery, honestly, in all aspects, I think, of paleoanthropology. One question that a lot of my viewers have had when I've talked about footprints previously, which has not been that much, is, and I'd love to readdress it. So you find these prints, these trace fossils. Now, we know that bone fossils are extremely fragile, and we need to do everything we can to preserve them for future generations, for study, for research. What do we do with the footprints? Are they just left there? Do we airlift them out? Do we bury them again? What do we do with them?
Yeah, so they're tricky. And I should say, like, I was just talking about the sort of places where we find them and, I should mention that there are lots of other contexts in which you find fossil footprints as well. Like footprints have been found in cave sites. They've been found
Hmm.
in volcanic ash, like at Laetoli as well, which is a very different setting than what we found at Kubiora. So I should mention that first, that there are all these different contexts in which they can be found. And then the approach to actually document and preserve them is going to be different depending upon which of those contexts you're dealing with.
Okay.
Um,
Yeah.
for the like open air sites that we're working with, our typical approach has been to document everything digitally, and so we do like 3D photogrammetry of the entire site so that there's a digital record in 3D of like this is exactly what it looked like after it was excavated, and then that gets curated by the National Museums of Kenya, and then that record is there should anyone want to access it in the future. Um, then there is a lot that we do to try to preserve the physical original site as well. Um, if if you have a case of like an individual footprint that's like sitting on the edge of an outcrop, like about to erode out and just sort of crumble and be obliterated. We have in the past done some like plaster jacketing of those
Mm.
and actually removed the sediment and taken that whole thing back to the museum
Oh.
for curation. It's I don't it's hard to say how much long-term value there is in doing that
Yeah.
because that is still probably going to break down and degrade over time. And the original digital record is like still going to be the best representation of what was originally there when it was uncovered. Um, for the rest of the site, so outside of those cases where you can do some plaster jacketing or something like that, our typical approach is just to rebury and then try to protect the site in whatever ways we're able, so that it can continue to last for generations to come. Like in many cases, these footprints, the layers aren't protected in any way. So when we find them, they're not typically like exposed to open air, at least
Hmm.
for these sites in East Turkana. There are sites where we have to excavate overlying sediments in order to get down to them. And then we're reburying them with those same sediments,
Right.
thinking that, that was good enough for 1.5 million years. And so hopefully it's going to be good enough for more years as well. But we have to do that in some careful ways, like some important lessons have been learned from like prior approaches at other sites. We use like sterile sand to rebury the site so that there aren't
Mm.
plant seeds or anything like that, so we don't introduce
Right.
plant growth to the site.
That's a good
Um,
point.
we'll do that and some like protective tarps that are sort of positioned at levels higher than the footprint surface. And yeah, basically try to, after we've excavated and documented the site, try as best as we can to return it to its original physical conditions so that it's reburied and can be there if someone, decades from now wants to go back and study that same site, they can do that. Um, in some places, I mean, it's rare. This takes a lot more financial investment. But there is one of the sites actually, the first fossil footprint site to be discovered in the Ileret area. I have been fortunate to be able to work with colleagues from the National Museums of Kenya, where we've worked to actually now build like a mini site museum that includes a
Mm.
protective structure that's built over top of the site, and includes lots of support structures so that the outcrop where those footprints are preserved doesn't erode. Um,
Right.
it's a huge investment to do that and takes a lot of work to do that. So it's not like something that can practically be done everywhere for every
Right.
case where we find these. But in that particular example, I think this is a really amazing way in which we're able to then preserve those footprints and also share them with the local community and share them with visitors who are coming, on the sort of like paleoanthropological tourism that goes through the
Yeah.
area.
Yeah.
Um, and so, yeah, at that particular site, we've been able to like at least, presumably for the long term, we've been able to expose some of the footprints in a sort of protective structure beneath protective glass, so that
Mm.
visitors to the site can actually see some of those
That's
trackways.
so cool. Yeah.
Um, And we have like continuous monitoring to make sure that nothing goes wrong with that. And we can sort of jump in and intervene if something starts to go awry.
Right.
Um, but then, yeah, it's part of this large museum exhibit and educational center that was built in collaboration with the local community. I think it's a great resource for them, and again, hopefully, like a great draw for tourism to the area as well. Um, but that's the sort of different end of the spectrum in terms of like financial cost for
Yeah,
a
absolutely.
conservation project.
Absolutely. But just a quick note on that, I think that is such an absolutely great thing if it did, especially since it's in collaboration with the local community that brings in funding, I'm sure, for the community, and tourism brings in resources to do more field work and whatnot. So I am very much for the establishment of these types of resources, and I'm so glad to hear it. And that's just so cool that you can go see. How old are those prints at that site?
Those are 1.5 million years old.
That's amazing that you can just go see under glass 1.5 million year
Yeah.
old hominin footprints. I mean, that is awesome. So I'm so happy to hear that that's a thing. So as we get towards the end of our discussion, is there anything that you, as your role as an associate professor, as a researcher, and as someone just involved in the field, is there anything you want to say, address, or talk to my audience who is quite diverse, but always loves to hear just the from people? They like to hear from people. Like anthropologists are people. And I think one of the big things that I do is scientists, I take the big spooky scientists and I make them the fun guy they can just talk to. So if you want to just take a moment, and if there's anything you want to say about anthropology or anything, or not, just go ahead.
Oh man, that's a tough one. Because yeah, I'm sure you have, so many people in different areas, in different professions, different levels, within your audience. So I don't know, like, if there's any big message that I can send that would reach everyone.
Let me
Um,
make it a little easier. Let me make it a little
yeah,
easier. So, for students, since I know you're involved with undergraduate
yeah.
work at the ABAs, what advice would you give to undergraduates who are looking to not okay, let's not put too much of a damper on things, but it's reality and we live in it. So, in the current situation in the United States, what advice can you give to undergraduates who are trying to pursue their studies and to finish and to succeed in anthropology?
Right. Yeah, I mean, I don't know
That
that
might be a
that's
worse question. I don't
I was
know.
gonna say, is that an easier question? I mean that also made me think of, general advice for anyone
Yeah.
is to look into, advocacy for science right now, given,
Yes.
the number of funding structures and things like that that are at severe risk, and we're at a real risk of losing some of those resources that the existence of our science and scientific enterprises in our country really depend upon. Um, a lot of those are sort of in jeopardy right now, thinking about our funding structures and things like that. Um, and so there's certainly a lot of advocacy work that can be done by anyone
Anyone.
in our
Yeah.
country.
Anyone. Yeah.
But then for students, I think like, yeah, I mean, it's a tough time to be a student. It's a tough time to be a graduate student. It's a tough time to be an undergraduate student. Um, it's it's hard to say like what advice I would give, because I feel like so much of the advice we give is based on our own experiences, and
Right.
what we're going through right now is so different from what we've gone through before. Um, yeah, I mean, I think there are a lot of ways in which people can sort of lean on their community that exists within our discipline for support as we all try to navigate this together. I don't think, anyone has any definitive answers or like a definitive, like, here's the playbook for what you need to do to make sure you can still be successful. But at the same time, everyone can be drawing upon the community that exists within the ABA, for example. There are lots of opportunities there for student support right now. That's something that we're really trying to ramp up. There are lots of opportunities for advocacy through that professional society as well, and lots of resources that are being shared there. And yeah, I think again, like students and faculty and other researchers and other people as well can also draw upon the resources shared by that community too. So I don't, that's not really an answer. I don't.
No, I think that's a perfect answer. I think that's a great answer. Sticking to your community. I think that's a great answer. And
Yeah,
that's one of the biggest lessons that I think anthropology has taught us. It's not survival of the fittest, it's survival of the friendliest, you
right.
know? And so we are all in this together. And I think that is a wonderful place to end this discussion. I want to thank you again so much, Dr. Kevin Hatala, for coming on. It has been an absolute pleasure.
Sure. Yeah. Thank you very much for having me. This has been fun.
All right. Thank you, everyone. And if you like and enjoyed this, please subscribe because there's plenty more to come. See you next time. Bye.